In this video we're going to be looking at the chemical process known as redox. So redox is just a combination of two words, reduction and oxidation. And a redox reaction is when reduction happens and oxidation happens. So next I'm going to have a look at the different types of reduction and oxidation that can occur. So the most obvious thing is when a substance gains oxygen. And we're just going to look at a displacement reaction for this. So this reaction where we react aluminium with iron oxide to produce aluminium oxide and iron is an example of a redox reaction. This reaction itself is known as the Thermite reaction. Produces a huge amount of energy and sometimes used to seal and fix train tracks because of the molten iron that's get produced at the end. So if you do get a chance, you can have a look at that video online. But first we're going to look at what happens here. Okay, iron oxide. We know that iron is bonded to oxygen atoms. What happens to the iron? Well, the iron loses the oxygen so this has been reduced. Why is it being reduced? Because oxygen is taken away from it. This is being oxidized because aluminium has gained oxygen. So this is an example of a redox reaction where aluminium gets oxidized to form aluminium oxide because it gains oxygen, and iron oxide loses oxygen and so has become reduced. So that's a redox reaction. So just to confirm there, we can see that the aluminium gains oxygen, so it's oxidized, and the iron loses oxygen and so is reduced. The next thing we're going to look at is how oxidation and reduction happens involving electron transfer reactions. So we're going to look at what happens when you react magnesium with chlorine, for example. We know that magnesium reacts with chlorine to form magnesium chloride. Magnesium reacts and forms a 2+ ion, and chlorine forms a chloride ion. So we're going to look at this in terms of electron transfer. So what happens to magnesium? Well, magnesium Mg loses 2 electrons because it gives those 2 electrons away to each chlorine atom. And now we look at what happens to chlorine. Chlorine will gain 2 electrons to become chloride ions, because if we think about it, magnesium chloride just exists as magnesium Mg 2+ ions and chloride ions Cl-. Okay, just so happens that there's 2 chlorides for every magnesium in the structure. So because the magnesium has lost 2 electrons, oxidation occurs here. And because chlorine gains 2 electrons, reduction occurs here. So another way to describe oxidation and reduction is that when a substance, like an element, loses electrons, oxidation occurs. When a substance gains electrons, reduction occurs. So we can remember that by looking at the mnemonic oil rig, where we say oxidation is loss and reduction is gain of electrons, that is. I'm going to introduce a new concept now, and the concept is called an oxidation number. So this concept of oxidation number, what is it? It's a measure of the number of electrons lost or gained by an atom in a compound compared to when it's in its uncombined form as an element. Okay, the leaving cert definition states that it's the charge that an atom has or appears to have when electrons are distributed according to certain rules. Essentially, what this means is we actually just compare an atom in a compound to that atom as an element, and we see what's the difference. So we're going to go through the number of rules, and I'm going to put them up and we're going to discuss them individually. So, the following are the rules for assigning oxidation numbers to elements and atoms within a reaction equation. So, any uncombined element gets an oxidation number of 0. That's there. Like carbon, sodium, hydrogen molecules, fluorine molecules, any uncombined element is 0. Any ion that you have is simply just the charge in that ion. So Na plus ion is just plus 1, chloride ion is minus 1. An oxide ion, O2 minus, would be 2 minus for the oxygen. A magnesium ion, which is Mg2 plus, because it always loses 2 electrons, will have an oxidation number of 2 plus. Next we look at a compound, and the main thing here we note is that overall in a compound the total oxidation number has to equal 0. So it could be methane here, it could be water, it could be calcium carbonate. Overall that compound will be 0. I'll be discussing polyatomic ions in more detail when we do the chemical formula section, but a polyatomic ion is basically an ion that contains atoms that are covalently bonded, but overall it has a charge on it. So the total oxidation number for the polyatomic ion will be the charge on an ion, similar enough to the total oxidation number of a compound being 0, and the fact that a simple ion, the oxidation number there is just the charge on the ion. So here I've got an example that a sulfate there has a total oxidation number of minus 2, just like an ammonium ion, NH4 plus, will have an oxidation number in total of plus 1. Carbonate, CO3 2 minus, will have an oxidation number in total of minus 2. Other ones, nitrates, NO3 minus, the total oxidation number there will be minus 1. Hydroxides, OH minus, total oxidation number there will be minus 1, etc., etc. So the next rule deals with oxygen. Whenever oxygen's in a compound, its oxidation number will be minus 2, such as water and calcium oxide. There are exceptions to this. Hydrogen peroxide, H2O2, in order to keep the total oxidation number of the compound equal to 0, oxygen's oxidation number there will be minus 1 instead of the minus 2. Also, in OF2, when you've got oxygen bonded to 2 fluorine atoms, because the fluorine is more electronegative, that takes priority, and that will happen in a lot of compounds. So the fluorine becomes minus 1, there's 2 of those, so that oxygen becomes plus 2. They're the only times where combined oxygen will not be minus 2. We're going to have a look at the following compounds and polyatomic ions and try to assign an oxidation number to each atom in that compound or ion. So, looking at SO2, we know it's a compound, so overall the oxidation number will equal 0. We have got a combined oxygen here, so each oxygen will be minus 2. Because we've got 2 oxygens, the sulfur will have to be plus 4. So just to recap that, oxygen is always minus 2. We've got 2 of them, so in total the oxidation number there from oxygen is going to be minus 4. We know it has to equal 0 overall, so the sulfur has to be plus 4. Now let's look at ammonia. We've got a hydrogen there. We know it's not bonded to a metal, so the hydrogen will have an oxidation number there of plus 1. We know there's 3 of them, so the oxidation number of the nitrogen has to be minus 3. This sulfite ion here, we know that overall the oxidation number is going to equal the charge on the ion, which is minus 2. So we need to get minus 2 from all of these overall. We know that oxygen will take preference of being minus 2. So if we write that in, minus 2, we know there's 3 oxygens, so 3 times minus 2 is minus 6. I need to get back to not 0 this time, I need to get back to the charge on the ion, which is minus 2, so I need to add plus 4. So sulfur must be plus 4. Now let's look at the manganate ion, a very common ion in chemical reactions. And we see that overall we have to get to an oxidation number of minus 1. Oxygen has an oxidation number of minus 2. We've got 4 of them. That brings it up to minus 8 in total. It's minus 8 now, we need to get back to minus 1. So we need to add 7. So the manganese there must be plus 7 oxidation number. We're now going to look at this chemical reaction here, where manganese dioxide reacts with hydrochloric acid to give manganese chloride, water and chlorine. And we're going to see if it's a redox reaction or not. I'm going to first start by assigning oxidation numbers to every atom in every compound. So, manganese dioxide. We're looking at these two here. We're not too sure about the manganese to start with, but overall it has to be 0. We know the oxygen is -2. Therefore, there's 2 of them, so the manganese has to be +4 because it always needs to get to 0 overall. We forget about the fact that there's 4 of these to start with. We know that each chloride is -1 and each hydrogen is +1. Here again, we're not too sure about the manganese, but we do know that chlorine is -1 because that exists as a chloride ion. There's 2 of them, so this manganese must be +2. Now we're looking at this and we see that it's water, oxygen is going to be -2 and each hydrogen is going to be +1. Now we have chlorine as an element on its own, so that's going to be 0. So now we decide, has oxidation occurred, has reduction occurred? So I can see I'm going from manganese to manganese. There is a decrease in oxidation number. So this must be reduction. Now I have a look somewhere else and I see that chlorine has gone from -1 to 0. Therefore, this must be oxidation because it has increased in oxidation number. So Mn plus 4 going to Mn2 plus. We're going from +4 to +2, that's reduction, and Cl minus going to Cl2, 2 Cl minus is going to that, is going to be twice -1 going to 0, which +2, and the other one is -2. So we know that the chlorine has been oxidized, the chloride ion has, and manganese, the manganate ion here, has been reduced, or the manganese ion. In this one, for example, we could see that the manganese loses oxygen, so it must be reduced. A couple of other definitions that we need to go through. An oxidizing agent is a substance that brings about oxidation in other substances. So here the oxidizing is the substance that allowed HCl to oxidize. So the oxidizing agent is MnO2, or specifically the Mn4 plus ion. And the reducing agent is the substance that allows something to be reduced. So here HCl, or the Cl minus ion, is the reducing agent. Oxidizing agent is the Mn4 plus ion because it allows the chloride ion to get oxidized. Reducing agent is the Cl minus ion because it allows the Mn4 plus to get oxidized.